Hello everyone. Today we are going to discuss this actually sample paper question. This sample paper was released by IIT Kanpur. All right, let's see how we can solve this. So a positive point charge Q is located inside a neutral hollow sphere conducting shell. The shell has inner radius A and outer radius B, and as shown in the figure, B minus A is not negligible, so we cannot consider it a shell of a thin shell basically, because this thickness matters in this case, right? This is B, this is A. The shell is centered on the origin. All right, let's mark this point 0, 0. If the point charge Q is located at the origin in the center of the shell, okay, this has a point charge Q, then which of the following options are correct? First, we need to figure out the electric potential at x equals to A. So we need to figure out the electric potential right here. All right. See, the way we can do this is we know the concept that in a metal with a cavity, we know that the charge is induced on this side opposite to the sign of inner charge, and then the similar sign of the inner charge is also induced on the surface, right? So to any body outside this uh, shell, it looks as if it only has this charge. That can only be possible in the scenario when the magnitude of this charge is negative q and this charge is positive q, right? This is how it would work, I suppose. So what they are asking us is ki the electric potential at x equals to A should be this. Now the electric potential at any given point, we are basically considering the locus of all these points, is given by all the charges, right? It is interactive, so it is given by all the charges. So we can consider it to be Q, KQ by B for this case, then plus KQ by A for this case, and then negative KQ by A for this case, the charge induced, the negative charge induced right here. All right. We have already studied that in a shell, if we are talking about the surface and charge is on the surface, then the electric potential there is also given by the expression KQ by X. All right. And if it is inside a surface and the charge is outside, so it is given by KQ by R. Even though this is X and this is R, it is still given by this expression. So with this we could approximate this, right? And this does equal this because this gets cancelled out and all we are left with is this. All right. This is a very core concept. This concept is named charge induction due to cavity charges. So the charge is inside this cavity, so it induces a opposite charge on the inner surface and like charge on the outer surface. Both have the same magnitude, which is equal to the charge present inside the cavity itself. Now the second question is the magnitude of electric field at x equals to A should be given by this expression. All right, so I think it's wrong straight out because this is on the shell, right? So we do not consider any field on the shell. The net magnitude of electric field should be 0, right? That is what it should be. Now moving on, the magnitude of electric field from x equal to a to x equal to b is not equal. Again, as soon as it's metal body, the electric field is going to be same. The electric field is going to be same as soon as the metal body starts. All right, it is equipotential. This surface is equipotential because there is no electric field here, because there is no charge inside this. So again, this should also be wrong. If the point charge q were to be moved to x equals to, okay, this is where we can consider 2a by 3. Right, this is where we can consider 2a by 3 at this place. Then the electric field for r greater than a. Okay, so electric field, what is the locus of r greater than a? It is this and all outside area. This also includes the metal surface, right? This is the locus of it. If you were to put it into Desmos, you would get this stuff right here. Let me just get the figure back. And it is given that it would be this. So this is again very much wrong. And the reason why it is wrong is because of the fact that we also need to consider that this also includes the metal surface. So if it was r is greater than b, then we could have considered it true, because then the whole shell acts like a point size charge. But because it is a conductor as written here, so the electric field is 0, and that is because the charge is actually at the shell and these two charges are cancelling out each other's electric field. That's why we get that this is also wrong. So the right answer should be this. Thank you.